Hi all, today we're looking at absolute value equations. First things first, we want to recall what the absolute value function is. If I take the absolute value of 5, the answer is going to be 5. If I take the absolute value of negative 5, well, the answer is also going to be 5. The absolute value is said to be the distance from that number to 0. A distance is always positive, and so the absolute value simply throws out negative signs. And what we're going to do is we're going to use this knowledge right here to solve this problem. If I were to ask you, well, what if the absolute value of an unknown number is 5, and I say, what is that number? Well, you should be able to figure out that that number has one of two possibilities. It is either plus or minus 5. And that takes us to our first rule for solving absolute value equations. When you drop the absolute value signs, when you remove the absolute value signs, you add a plus or minus to the other side of the equation. You add a plus or minus to the other side of the equation, and that helps us get to our answer. So let's try an example that's a little bit harder. So let's say I have the absolute value of x plus 3 is equals to 10, and I'm trying to solve this equation right here. I want to get rid of those absolute values. So I remove them, and that leaves me with x plus 3, and I introduce a plus or minus on the other side. And so what that tells me right here is that I have two equations to solve. The first equation is that x plus 3 is 10, and the second equation is that x plus 3 is equals to negative 10. Both of those are one-step problems. I simply subtract 3, so x equals 7. I subtract 3, I subtract 3, so x equals negative 13. And those are my two answers. Now I should check those answers by plugging them back in, but when you plug them back in, you realize that both of them do give us 10, and so that is our answer. Now, sometimes the absolute value sign is not alone. Consider this example. Let's say I have 2 times the absolute value of 3x minus 2 minus 5 is equals to 7, and I need to solve this equation right here. What I notice is that my absolute value is not isolated. I got this 2 and I got this negative 5. And so what I have to do is I have to get rid of them first. And so we work PEMDAS backwards, and so that means I got to get rid of the 5 first, and so I'll add 5 to both sides to make it go away. 2 times 3x minus 2 equals 12, and then I divide by 2, and so it gives me absolute value of 3x minus 2 is equals to 6. And now I am in business. Now I can drop my absolute value and introduce my plus or minus on the other side. And so I will have 3x minus 2 is equals to plus or minus 6. And we have two equations that we need to solve. 3x minus 2 is 6. 3x minus 2 is negative 6. I add 2. I add 2. I had to add 2. And so that leaves us with 3x is equals to 8. And that leaves us with 3x is equals to negative 4. The last step is to divide. And these right here are our answers. X is 8/3. And x is equals to negative 4/3. You should check those answers by plugging them in. Again, when you plug them in, you'll see that they both work. Plug in the 8/3 and the negative 4/3. Sometimes these things don't work out. Sometimes life is just not perfect. Let's take this example for example. Let's say I have 3 times the absolute value of 5 minus x plus 12 is equals to 6 right here, and I'm trying to solve this equation. So what I'm going to do is I'm going to subtract 12 from both sides. And I will have 3 times the absolute value of 5 minus x is equals to negative 6. Divide by 3. Divide by 3. Absolute value of 5 minus x is equals to negative 2. And now I drop my absolute value, and so I have a plus and minus on either side of my equation. So I have 5 minus x is equals to plus or minus negative 2. Solve my two equations. 5 minus x is equals to plus negative 2. 5 minus x is equal to minus negative 2. Plus and a minus is a minus. 5 minus x equals negative 2. 5 minus x, a negative, and a negative is a positive. And then 2 steps to get home. Subtract 5, subtract 5. Negative x equals negative 7. Divide by negative 1. X equals 7. Subtract 5, subtract 5. Negative x equals negative 3. So x equals 3. Well, it looks exactly the same, kind of. But if I try one of these answers, I will see that they don't work. If I take 3 and I plug 3 into the original problem, well, 5 minus 3 is 2. The absolute value of 2 is 2. 2 times 3 is 6. 6 plus 12 is 18. So therefore, this answer is not correct. If I try the same thing with 7 right here, this will also not work. And so the answer to this problem is actually no solution. Well, you might be wondering to yourself, why? Why? What did we do wrong? Well, what we did was we missed something. If we go to the center of the problem right here, right when we isolated the absolute value sign, we got this statement right here. We said the absolute value of 5 minus x is equals to negative 2. I put it to you that this is impossible. When you take an absolute value, you always get a positive answer. Whenever you take an absolute value, you always get a positive answer. And so it is not possible to take the absolute value of 5 minus x and get negative 2. And therefore, everything else did not make sense. Whenever you get something that's impossible, the answer is automatically no solution. Nice, right? You can just stop right there and then go on about your business. So far, on the first few problems, we got 2 solutions. In this problem right here, we got no solutions, 0 solutions. Is it possible to get 1 solution? Consider this problem right here. Let's say I have 2 times x plus 3 plus 5 is equals to 5, and I am trying to solve this equation. So I go ahead and subtract 5 from both sides. I get 2 times x plus 3 is equals to 0. I divide by 2. I divide by 2. I get that x plus 3 is equals to 0. I drop my absolute value. I put a plus and minus on the other side. So I have x plus 3 is equals to plus or minus 0. But 0 does not carry a sign. Does it really make a difference the adding or you're subtracting 0? Of course not. And so that tells us then that I really have x plus 3 equals 0 as my only equation. And then I simply gotta subtract 3. Subtract 3, subtract 3, x equals 3, and this is the only solution. I know, right? So when we have one absolute value and we're trying to solve the equation, so far we've seen 1 solution. We've seen 0 solutions. We've seen 2 solutions. Can we get 3 solutions? Well, to investigate that question, what we need to do is we need to investigate the graphs of absolute value equations. Let's say I wanted to solve this right here. The absolute value of x is equals to 3. Well, the absolute value is a v. This is y equals the absolute value of x. And then 3 comes across this way. This second line is y equals 3. To find the point of intersection between two graphs, I simply need to find where they meet. And so the graphs meet here, which is at -3, and the graphs meet here, which is at 3. So this equation right here will have two solutions. X equaling -3 and x equaling 3. You get those two solutions because the line y equals 3 intersects with the absolute value function exactly twice. On the other hand, if you have the absolute value of x equaling 0, then this right here is my absolute value, y equals the absolute value of x. The line y equals 0 will be the horizontal. The line y equals 0 will be the horizontal line on the x-axis. And if you look carefully, you'll note that the two graphs meet only once. These right here meet twice. This graph meets only once. And so here we have one solution. X equals 0. Last but not least, if I have the absolute value of x equaling -4, again, my absolute value function, -4 is down here. The line y equals -4 goes across, like so. And if you look carefully, you'll see that these two graphs never meet, and so therefore we have no solutions. All of these come from simply shifting the horizontal line up and down. It was up here, then it came down here, now it is down here. So those are the basic three possibilities. And so if an absolute value function, when you have one absolute value, you can either get 2, 1, or 0 solutions. Let's look at one more example before we hit the road. Let's say I have 1/3 of 2 minus 2/5 x plus 5 is equals to 7, and I am trying to solve this equation right here. Now, no biggie, you subtract 5, and so you have 1/3 absolute value of 2 minus 2/5 x is equals to 2. Then you multiply by 3 to cancel the 1/3. And so these will cancel. Absolute value of 2 minus 2 over 5x is equals to 6. Again, the reason why we isolate the absolute value is because it tells us something about our answer. If we isolate the absolute value and we get a regular number, we will get two answers. If we isolate the absolute value and we get a negative number, we get no solutions. If after isolating the absolute value we get 0, we get one solution. And so that's why we try to get the absolute value by itself first. We're going to have two answers right here. Drop my absolute value, and so 2 minus 2 over 5x, drop the absolute value, it's still there, go away, is equals to 6, subtract 2 from both sides. So -2 over 5x is equals to 4. I'm going to multiply by 5 to cancel the denominator. These cancel. -2x is equals to 20. And then I divide by -2. So x is equals to -10. On the other hand, 2 minus 2 over 5x is equal to -6. Remember, plus or minus. I am going to subtract 2. And so I will have -2 over 5x is equal to -8. Again, I multiply by 5. Hopefully, you notice we do the same thing each time. multiply by 5, and so that's negative 2x is equals to negative 40, and then I divide by negative 2. X is equals to 20. We do not need to check these answers. We got past this critical line right here, so we know both of these answers are correct. Don't forget to subscribe so you can get access to all of these videos all the time.